Okay, welcome back. We're continuing with Trigonometric Identities, Example 6. Moving on to Requirement B, hence, and a comment regarding the word hence. Hence instructs you to use prior work. So we want to use what we did in A and apply that to the requirement in B. Hence, sketch the graph of y equals sine x minus root 3 cosine x. Our application is going to be that we'll change the right side of the equation based on our work in requirement A. We know that sine x minus root 3 cosine x equals 2 sine x minus pi over 3. So now I'm going to graph 2 sine x minus pi over 3. Now before doing that, I want to go back and add some accuracy to a couple points in requirement A. In the last line of requirement A, I've written an equation. And actually this is an identity. For whatever x value we input, the left side will match the right side. Thus we have an identity. Now let me go back over to the left side of the screen. The first line in step 3, I'm also going to change my notation from equation to identity because we have the same situation there. Once we move to step 4, we are in fact working with equations, and now in requirement B we're working with specifically a function. Given a particular x input, we will arrive at a particular y output. So let's graph this function. I'll add in a coordinate plane. And now evaluating the function based on learning from IGCSE or A-Level Pure Maths 1, the coefficient in front of the sine function gives me information about the amplitude of the curve, and the x component as x minus pi over 3 gives me information about the horizontal translation of the curve. So I'm going to mark up my coordinate plane. An amplitude of 2 tells me that the height is 2, and the low point is negative 2. We don't have any vertical shift. There's no plus or minus after the sine function. So an amplitude of 2 means from the origin up 2 and from the origin down 2. Sine of 0 at the origin would have a y value of 0. In this case, sine of x minus pi over 3 means that instead of starting at the origin, we're going to start at the point pi over 3. And for our sine function at that point, x minus pi over 3, by choosing an x value of pi over 3, sine of pi over 3 minus pi over 3 is sine of 0. And that output, sine of 0, is 0, as is 2 times, in this case, sine of 0. Now from here, I know that one complete cycle is 2 pi. Since we're beginning at pi over 3, we'll complete our cycle at 2 pi plus pi over 3, which is 7 pi over 3. And 1/2 cycle is the distance of pi. So from pi over 3, adding pi, we'll end up at 4 pi over 3. Moving to the left of our starting point, pi over 3, we'll have another distance of pi. Pi over 3 minus pi is minus 2 pi over 3. Now we haven't been given an interval for the graph. I'll start at negative 2 pi over 3, down to negative 2, up through pi over 3, up to 2, down through 4 pi over 3, down to negative 2, and up through 7 pi over 3. This is the graph of the function y equals 2 sine x minus pi over 3. We've completed both requirements, and this concludes Trigonometric Identities, Example 6.